Alright guys, let's begin. Where now? Look at this. First thing I'm going to do is I'm going to multiply it out. If I multiply it out, I can have a better idea what I might get away with. Sine squared A minus sine A sine B plus sine B sine squared B. I'm only doing the left hand side, not the right hand side. That's it, yeah, so far. I now compare the left side to the right side. On the right side I see a minus sine squared B. Yes, I haven't multiplied that out properly just yet. So then it's plus sine A sine B, and then it's minus sine squared B. Now, if we look very forensically at this, okay, the two of them cancel. Would you agree with that? Yeah. And sine squared B is matched up with the other sine squared B. What's not matched up is the 1 minus cos squared A is matched up with the sine squared A. So is there any way I can change that? Come on guys, you all know it. What? I realised that I had to exchange sine squared A for 1 minus cos squared A. I found the formula that does that for me. It's in page 14 of your notes, and then I moved the cos squared A over your sides. Now I'm going to do a direct swap for this here. It's going to be 1 minus cos squared A minus sine squared B. Who got that one out?
Isn't it a half? 1 minus cos squared A?
No, you're looking at the wrong one. Not looking at that one. Page 13. Okay guys, ready? Moving on? Okay. That's the same question, is it? Did I do? Oh, it looks very similar. Okay. I have two options with this. I could say that the left hand side is a half. Do you guys remember me doing this trick before? You must remember me doing this trick, yeah?
Yeah.
And why did I do that? So effectively what I have there is I effectively have 2 sine x sine y. And there's a formula for that, isn't there?
Yeah.
The formula is located on page 15. It's a double sine. So because x minus y minus cos x plus y. That makes sense? What's x? And what's y? Let's do this now. Cos x minus y. A plus b minus the second one minus a plus b. And then the other one. Add them together this time.
2a.
A plus a, 2a. Plus b minus b. Nothing, right? Gone. So that will be cos 2b and minus cos. Compare. So, and we forgot the half, didn't we? There's a half on the outside, isn't there? Yeah, do you remember that? So the whole thing is multiplied by half, so it's a half cos 2b. Okay. Notice the presence of a cos squared b and a sine squared a. Let's see what we can do with this. So what I'm going to do is I'm going to look up a formula for cos 2a. What's cos 2a? Cos squared a minus. Would you agree with that?
Yeah.
So what's cos 2b? cos 2b, guys.
Same thing as that, just a b.
Yeah, so,
Cos squared b minus sin squared b.
yeah. And then minus the cos 2a, so minus that.
Minus cos squared a plus sin squared a.
Yeah. Now,
Is that not going to cancel itself out then, no?
how they're different angles.
Right.
One's black, one's A, one's
Yeah,
blue.
yeah, yeah.
Now, the whole point is that I get this here. So, just want to. That's my aim, yeah? Now, cos squared b's are allowed. That's allowed. Sin squared a is allowed. What's not allowed is the sin squared b and the cos squared a. Do you see that logic? Now, how do I get rid of them? Well, sin squared b plus cos squared b equals 1. Therefore, sin squared b equals 1 minus cos squared b. You happy enough with that? Likewise, to get rid of the cos squared a, what would I say there? Cos squared a is 1 minus sin squared a. I now have two direct trades to get rid of the ones I don't want. How are you guys? So, here's what we're going to get. We're going to put in a half cos squared b minus, what am I putting in here? Have it there, guys. What am I putting in? That one. And then for the cos squared a?
Minus sin squared
Look what's about to happen.
a. How are you?
Just give me a sec. Cos squared b plus another cos squared b. Anybody? And then this one. Another minus 1. What's minus 1 minus 1? Huh? And then a plus sin squared a plus another sin squared a. Half everything. And what you get?
Cos squared b.
Plus sin squared a. So it's all about comparing to your answer. Now, which one I'm allowed, which one am I not allowed, how can I change it? That's how you do it. Now, this one. I did this one yesterday, but look, we'll drive through it again. Okay. What you read that as in the notes?
2 sin a cos a.
2 sin a cos a. If I can prove that the left side equals the right side, I've proved that identity, yeah? How many functions do I have at the moment?
3.
I have 3 functions.
Oh, you include the
I have
left.
sine, cos and tan. Can somebody tell me a method to reduce them down to 2 functions?
Change time.
Okay. Yeah, in here.
Sin squared a over cos squared.
Okay. And after that?
Bring it up. Oh, comment on it and then bring it up and flip it.
Yeah. What can I do with the number 1?
Put a cos squared a.
Cos squared a plus sin squared a?
Cos squared a sin squared a. Oh, 1 second.
1. So 1 over cos squared a? Yeah? So? Where? Now, bring it up and flip it. Now what? Cos squared a means cos a by cos a. And then what am I left with?
2 sin a.
We good? Now, hence or otherwise. What's the really nice word? Hence. Hence. Here's what you're going to do. So 2a equals a half. Anto stole the car. Now what? Sine inverse a half, and you get 30 degrees. But you also get 150 because the second quadrant. Divide by 2.
15,
And we get it.
That's falling apart.
Took longer than expected. Now, this one here. Okay? Now, the logic is with this one, and there is a lot of logic here, right? So what I'm seeing is that I'm seeing that the one on the right only has cos theta, but the one on the left has sine and cos theta. What would be my logical step therefore? Change sine into cos. Yeah? Everybody see that? This one has sine and cos, this one only has cos. I should do anything I can to change sine into cos. So how do I do that?
1 minus cos sine.
Well done. You get the logic, yeah? Put it in. Now what? The 1 and the minus 1? Root 4 cos squared theta. What's the square root of 4x squared? Anyone tell me? 2x. Let me explain why. You can break that up into root 4 by root x squared. What's root 4? What's root x squared? So we're going to do the same trick here, aren't we? Root 4 by root, and therefore
2 cos theta.
now another way root 4 can be either plus or minus 2. That's why we put in the modulus signs to say, look, it can be positive or negative. We good? Oh dear, hence graph that. Yeah, that ain't gonna happen. And that ain't gonna happen, and that ain't gonna happen. Oh, hence. Oh, wait. Yeah, you don't have to do that. Sorry. 2, 3, 4. You haven't done graphs yet, so we're not bothered with that right now. Is that alright with you guys?
Yeah.
Now, if you were basically, so if you were asked to graph this, you'd be saying you're out of your mind not graphing that, right? But we're just after proving in part 1. What did we prove in part 1? That that is the same as that there, yeah?
Yeah.
Go to our calculator. Go to our table function. Anybody see the modulus signs anywhere? They're there somewhere. I think it's this. There we go. Absolute, yeah? What do we put in? 2 cos x, yeah? It wants me to go from 0 to 180, doesn't it? 0 to 180. I'll go steps of 15. And look, there's my graph. All I have to do is draw that out, don't I? And then see if I can do it here. I don't remember the sign for absolute, so I'll give it my best shot. I think it's ABS. There we go. Oop. There we go. Absolute means it always has to be positive. And you see the way this never goes below the x-axis, does it? So, and then I'll just check my thing to make sure. What did I start off with? 0, 2, and then when did I hit 0? I hit the number 1 at angle 60. So where is 1? That's 60 degrees there.
It's supposed to be 0, 2.
90 is 0, so there's 0. And then 180 is 2. Where does it go up to? Oh, sorry, it's meant to be 2, isn't it? Is that right, 2 cos x?
Yeah,
Huh?
I think you're right about that.
Oh, in here?
Yeah.
I didn't actually, you're right. So, file, undo. So that my graph is slightly different than the one I want, so I'll just undo that. Undo. Undo. Right, let's try this again. Y equals 2 times the ABS of cos x. There we go, that's a bit better, yeah? So, you guys would have been able to draw that using your calculator, wouldn't you? So, there it is there. Now we're going to look at the graph again, compare. 0, 2, yeah? When does it hit 0? Let's find out. 90 degrees in, it hits 0, would you agree with that? Then, when does it hit 0? So, it starts off at 2, doesn't it? And then it ends up at 2. Remember we said earlier in the year that, remember we said starts at 2, ends at 2. So if it starts at 2, ends at 2. Starts at 2, ends at 2. There, it's pi, isn't it? 180 degrees is the period, would you agree with that? From tip to tip is 180 degrees. So we say that our period is 180 degrees and our range is 0 to, anybody? 0 to 2. You alright with that? Last question. Solve it. Solve this equal to root 2 in the given domain. Well, what do we know this is equal to? Square both sides. 4.
Cos squared theta equals 2.
Sorry?
Cos squared 2.
A half, yeah? Root both sides. Cos theta equals square root of 1 over 2, which is root 1 over root 2, which is 1 over root 2. Cos theta equals 1 over root 2. What's theta? Well, it's 45 degrees when you cos inverse. And you're done. Okay, guys.